check by SITS. Divisibility check by SITS. Divisibility test by SITS. Okay. If a number, you are writing a number, (324). This is an even number. Okay. So it is divisible by 2, that you know, exactly divisible by 2 because it is an even number. And check the, add the digits. 3 plus 2 6, 3 plus 2 5, 5 plus 4 9. So it is divisible by 3 also, that we have studied earlier. When the digits are adding, you will get a number which is multiple of 3. That is, we got here 9. 9 is multiple of 3. So this number also multiple of 3. Then you have to check whether it is a even number and multiple of 3. Then this number is divisible by 6. Divisibility check for 6 is not complicated. If it is an even number and if it is divided by 3, that means you have to check divisibility by 3. By adding the digits, you will get a number which is a multiple of 3. Then the number can divisible by 6. Number is divisible by 6. Let us check. (324) divided by 6 is, you will get 54, exactly divisible by 6. How will you check divisibility by 6? If it is an even number and if it is divisible by 3, then the number can divide with 6 also. Okay? That is all for divisibility check by 6. And 8. Next is 8. When you are dividing 4, we told that the last 2 digits will be a multiple of 4 or it will be 2 zeros. For example, 2000. 2000, I forgot to say this, mention this, that is why I am telling here 2000. Last 2 digits are 0. So it is divisible by 4. So divisibility check for 4 is, last 2 digits will be either multiple of 4 or 2 zeros. Okay? Like this, divisibility test for 8. It will be taken for only larger numbers, I mean 4-digit numbers. Okay? Last 3 digits will be multiple of 8. For example, 416, 8. If it is divisible by 8, then the whole number is divisible by 8. That we can check. Sorry. So, 177. It is exactly divisible by 8. How will you check? The last 3 digits you will check. Then if it is divisible by 8, then the whole number is exactly divisible by 8. That we have checked here. So it is proved. And also, if you have a number like this, last 4 zeros. So 9, next one number is 9. If you check the divisibility by 9, if you add the numbers, digits of the number, then if you get the number a multiple of 9, then the number will be divisible by 9. Like the 3, we have done in 3, that is the same procedure is here for the divisibility check for 9 also. Okay. For example, 2358. You add these 4 digits. You add these 4 digits. 2 plus 3, 5, 5 plus 5, 10, 10 plus 8, 18. So, let us check. 2, 3, 5, 8. 18 is multiple of 9. So, 9. Okay, it is exactly divisible by 9. So, we have proved that 9, when you add the digits of a number, you get the multiple of 9, then the number is exactly divisible by 9. You do not want to check this, I just proved this like this, okay, by doing this. You just do the test for divisibility. Then you will get such answers which is multiple of 9. Then it is clear that that number is exactly divisible by 9. Divisibility test by 11. For this 4 digits numbers, like the bigger numbers we are taking, okay. Smaller number you know, 11s, multiples of 11s are, 11 is multiples of 11 are 22, 33, 44, 55, 66, 77, 88 and going on, okay, 99 like that. But in big number, when we are given a big number, bigger number, how will you find whether it is multiple by 11 or not, okay. Whether it is a number which is a multiple of 11. We are giving, taking an example. 1331. You have to check the sum of the digits at odd places. Okay, first, second, third, first and third. Sum of the digits 1 plus 3. From here, from right. And what is the sum of the digits of even places? 3 plus 1. This is 4, this is 4. So, when you are subtracting both this, you will get an answer 0. Or if you are getting 11, then also this number is divisible by 11. Okay, how will you identify a number is divisible by 11? This is the method how to check. From the right of the number, you have to take the odd places, okay. First, third, then add these 2 digits, 1 plus 3, 4. Then even places, 3, this is second and fourth, 3 plus 1, 4. Then subtract these two numbers, then you will get 0. That means this number is divisible by 11. Give another example. 61809. 61809. Look at the digits at odd places. 9, 8, 6. 9, 8, 6. 23. These are odd places, first, third, fifth. And these are even places, 0 and 1. 0 plus 1, 1. Okay? 0 plus 1, 1. Then you subtract these numbers. 22. 22 is multiple of 11. 22 is multiple of 11. So, this number also multiple of 11. How will you check the divisibility by 11? You have to take the odd places digits, then add the digits, then even place digits, then add that also, find the difference. If you get an answer 0 or multiple of 11, then that means the number is divisible by 11. Okay? So, children, this is all for the divisibility test. Now, we are going to study what is common factor and common multiples. Okay, highest common factor, least common multiples. That means LCM and HCF. Before doing that, you have to know how to factorize prime factorization. Prime factorization, okay. 24. Let us factorize it. 24 is 2 into 24. Okay, sorry, 2 into 24 is 2 into 12. Okay. Then 12 you can still factorize. 12 is 2 into 6. Okay. And hence we can divide this still, or you have factors of this number. That means 2 into 2 into 6 is 2 into 3. Can we factorize this numbers still? No. These have no factors. These are prime numbers. Such factorization is known as prime factorization. That means at the end of the factorization we are doing, or we will get at the end all numbers prime factors, prime numbers. So, this is known as prime factorization. Another method of prime factorization is 24. First you divide with the smallest number. That means smallest number which is divisible by every number is 2. So, 1 2s are 2, 2 2s are 4. We know 24 is exactly divisible by 2. So, we have divided it. And 12 also even number. So, we can divide it with 2. 12 also we can divide with 2. So, 6 2s are 12. Again 6 is even number. So, we are dividing it with 2 and we get 3. Can we divide any more? No, 3 is divided by itself only. So, 1 3s are 3. So, we can write 2 into 2 into 2 into 3. These are the two methods of prime factorization. Either method you can use, which is simple for you, that you can use. Okay. Now, what is HCF? We are going to study HCF, means highest common factor. You are given 3 numbers, 20, 28 and 26. We have to find out which is the common factor among this. These will use in practical life, means 3 tanks are there which will fill, or workers are there, like that. Such sums we have to take common factors. Okay? And then we will get the answer. Such example is coming after the basic of this after you learn the basic of this. Okay. So, let us study HCF. 20, 28, 36. 20, 28, 36. Find HCF. HCF means highest common factor. First we can do this 20, 10, 5, okay, 28, 2, 1 2s are 2, 4 2s are 8, 2, 7 2s are 14 and this is prime number, so only 7 is there, 1 7 is there and 36, 2, because it is an even number, so we know it is divisible by 2, the half of this, or you can do like this, 3, how many 2s are there in 3? 1 2s are 2 and remainder 1. Okay, 3 is this, 1 2s are 2, then 1 is the remainder, then next number is 16, 8 2s are 16, then 2, this is also divisible by 2, 9. And 9 is not divisible by 2. So, we are going to the next number 3. 3 3s are 9, 3, 1. So, which are the factors here? 2 into 2 into 5, 2 into 2 into 7, 20 equal to 28 is equal to and 36 is equal to 2 into 2 into 3 into 3. Okay, 2 into 2 into 5, 2 into 2 into 7, 2 into 2 into 3 into 3. But we can check whether all of these have which are the common factors. Only 2 into 2. 2 is there. All these numbers 2 is a factor. Another 2 also is there. Another 2 also is there. And is there any common factor among 3? No. So, only 2 and 2. 2 into 2. Then HCF of these numbers is 2 into 2. That is equal to 4. 2 into 2 that is equal to 4. Another easy method I will tell you. I don't know whether it is work or not. I will show you. We can take all these numbers together 20, 28, 36 together. Okay. Then it is divided by 2. Okay. 10 2s are 20, 1 2s are 2, 4 2s are 8, like that 1 2s are 2, 16, 8 2s are 16. All these are even numbers. Again we can divide with 2. 5 2s are 10, 7 2s are 14, 9 2s are 18. Is there any common divisible number for these? Not any number which is divisible for all these number. Okay. So, the answer is 2 into 2. 2 into 2, HCF is equal to 2 into 2, 4. This method also you can use. Next, we are going to learn LCM, least common multiple. LCM. LCM of 12 and 18. 12 and 18. As we have done 12, write the factors of 12. 2 into 6. That means 2 into 2 into 3. This is prime factorization. Or you can do like this 12. 6 2s are 12. 3 2s are 6. Like this also you can write. This is 2 into 2 into 3. This is also 2 into 2 into 3. Another number is 18. 2 into 9, 18. 9 again we are splitting 3 into 3. Okay. Here, this method 18 divided by 2. Okay. 9. 3. 3. Okay. Now we are writing this 2 into 2 into 3 is here, 2 into 3 into 3 is here, which is least common multiple. That means in both of this 2 into 2 into 3, that means most time which is repeating here, 2 is repeating here most time. So, we are taking both 2's. Okay. Here only 1 2, here 2 2's are there. So, we are taking both 2's. And most time 3 is repeating here. Okay. So, every number which is most time coming, that numbers we are taking. So, this is least common multiple. 2 into 2 4, 4 into 3 12, 12 into 3 36. So, the answer is 36. Next one is simplest method, I mean not like this. It is a complicated way, or it is a complicated, it will be complicated for you. So, I will show you a simple method. First, you do not mind this 25. If there are two numbers which is divisible by 2, you can divide the first with a 2. So, 10 2's are 20, 25 we are writing still like that, and 30, half of 30 is 15, or 1 2's are 2, 10, 5 2's are 10. Next one, now again we can divide 10 divided by 2. So, we are writing 2 again, 5, and we are copying the same numbers here because you can't divide it with 2. In this, not like in the HCF. HCF, all numbers should be divided with this number. But here it is not necessary, at least one number should be divided this number. Okay. So, the smallest number we will take, smallest prime number is 2. Next 3, 3 we can't, yes, 3 we can divide with 3, 15. So, 5 we are writing here, 25 writing here, 5 3's are 15. Okay. Now, all this number we can divide with the 5. 1 5's are 5, 5 5's are 25, 1 5's are 5. Again 1 5 is the 5, 1 1 1. At the end you should get this 1 1 1. So, the answer is 2 into 2 into 3 into 5 into 5. How will you multiply all this number? This is an easy method. 2 into 5, 10. Okay. And again 2 into 5, 10. 10 into 10, 100. 100 into 3, 300. So, the answer is 300. So, children, I hope you understood this LCM. You can write it together and you can divide one by first smallest prime number you will take. Then if the division is over with that number, you can take the next prime number. Then the division is over by that number, then you can take next prime number which is divisible by all this. In at least one of these numbers should be divided with that. Then after this is the 2 into 2 into 3 into 5 into 5 is the least common multiple of these three numbers. So, you have more examples in your textbook, you try and hope you understood everything of this lesson, and I am winding up